Hello, in this video, I want to talk about a very interesting interview question, and it's called find the maximum depth of a binary tree. The question goes like this: your function should take in the root node of a binary tree, then returns the maximum depth of that binary tree. So if we have a binary tree look like this, we should return 4. So we have 4 level, as you can see here. So the most popular solution to this question is a recursive function that only has 2 lines. All right, but the first time I saw this question, I actually read a solution that takes a lot of lines. So I thought to myself that we should probably discuss this and think about how come there is such a good solution that only takes 2 lines, whereas if I wrote it intuitively, it takes so many more lines to achieve the same thing. All right, without further ado, let's get started. So function, the first time I saw this, I come up with this solution. So takes in a root node, right? And let's call this function maximum depth. And then the first thing I thought to myself is, what if the root node is empty? So if root node is a false value, we return 0. And if not, meaning we have already got our level 1, so we can initialize a count called the maximum count. And let's initialize it with 1. Then I thought to myself, I should probably write a recursive function that's going to immediately invoke itself. So trace should take in a current node and initialize it with a depth value equals to 1. And the first layer should be our root node. And then let's describe our base case when the current node is left is equals to null, and current node dot right is equals to null. In that case, if our depth is bigger than our maximum count, then we should update our maximum count by our depth. Okay, end of this if block. The base case is finished, and then let's discuss what happens when we have a child node of our current node. So if this exists, we should do a trace and passing the current node dot left plus depth plus 1. And let's do the same for our right children. If it exists, we should passing this into the next layer, calling it recursively. Then in the end, we just need to return our maximum count. So let's try our solution. Test our solution. Console.log maximum depth, passing a root node. Okay. Find maximum depth of binary tree. Okay, returns 4. Great. So as you can see, it takes more than 10 lines for me to write this solution, but actually it's a better solution that only takes 2 lines. So let me describe to you. Let's just call this function maximum depth, and let's just call this parameter current node. And if current node equals to null, return 0, and else return 1 plus max. Okay. Great, so let's test our solution. Okay, immediately we got 6. That means we did the thing here wrong, not plus dot maximum max. Okay, 4. So this should be the 2-liner solution, which is very which is great. And the key here is, when we passing, when we takes in the question, it takes in the root node, right? And immediately just thought this should be a single parameter, but actually a root node is just like all other node. It share the same properties as the all other nodes, so we can squeeze these down, taking the root node as just the current node and use the original function as the recursive function, and we can actually use max and like these things. Our recursive function should boil down and bubbling up back towards the first layer. Then we can just check whatever solution that is the whatever uh, tracer that come up with the biggest count. So I thought this is really something to think about and something to wrap our head around. So, all right, so this is typically how we can find the maximum depth of a binary tree, and I hope it's insightful. Thank you for watching, and have a good day.